Hello and welcome to the third video of my programming tutorial in Pygame. Now, if you remember last time, what we had going for us was we had this blue cube that turned red when we moved it, and it turned black to blue, but we deleted the code that did that, so it's just a red cube and it moves super fast and is pretty much uncontrollable, so it's not very good. What we're going to do in this video, mostly, is we're going to clean up the code. We're gonna change up this thing, basically add the frame rate so it, moves a little more predictably. Clean up these background images because we don't need these boxes anymore. They're kind of useless at this point. And since this is going to be a shooter game, I don't know if I mentioned that, we're going to start creating some ammo for our player so that, he can have some kind of storage of ammo that he's going to shoot out at the enemies when we get to them. We're not going to get to the enemies yet. We're going to focus on the ammo. And I don't think I mentioned this, but if you want a better name for this game than this, as you start, actually seeing what the game's going to be about, feel free to pick a name, and if I like it, I'll put it in there. So let's get started with our example. Let's see, run previous example, pre-video example. So what you're going to notice is we have this blue box. He moves a little bit slower, but that's not the thing that's really interesting about it, is it? What you're probably noticing is what the hell are all the A's doing? Well, there's a whole bunch of A's in there. Each of these are being spawned inside of the box, and when they hit an edge, they just kind of bounce. And then there's that couple stuck at the bottom that just kind of hilariously bounce up and down for reasons. I know why they do that, and I know how to fix it, but that's just me quickly putting them in there. Some of them do that, but the rest of them just bounce off the walls and kind of fly around and slowly fill up. Two of these get spawned a second, so I mean we could wait here for an hour and this whole box would probably be completely black from all the A's bouncing around, and it might go a little slower, but we'll have to see. We're gonna work on doing this, and also if you noticed when I move, none of them are actually affected by the movement. They don't really care because their position isn't dependent on where this box is. Their position is dependent on the box position itself. So this is what we're going to work on making. Let's close to this and come back here. So first off, I want to actually probably clean up the code, to be honest. So let's see, we don't need to draw this rectangle anymore. We also don't need so many spaces, and we don't need to draw any of this stuff anymore. We just need the fill in the game window. So fill, I'm going to change up the comments a little bit because good comments are always a bonus to have. So under here I'm going to say draw stuff with one F here, and then just before the update I'm going to say end drawing stuff, just because that gives you kind of a better idea that you stop drawing stuff and then you update, and then you fill it with white first and then you start drawing. So this is just how I'm going to organize it. We have our quit. We don't need to print events anymore. I don't think we'll ever really do that, and it's not like it's a long line to put back in. So I'm just cleaning up the code to make it a little bit nicer to look at. Let's see, we aren't going to fill this box anymore, so that's irrelevant code. And I'm doing this on camera. Normally I could just clean this up very easily off of camera, but I want to make sure if you notice any changes in how the lines and everything is changing in between last video and this one, you'd actually be able to see what was really happening versus just going, whoa, everything looks different, I don't know what's going on. Okay, so the first thing I want to do is set up a frame rate because our box still moves way too fast. So we're going to create a variable and we're just going to call it clock. And that is going to be equal to pygame.time.clock is what I believe it is. Maybe it's uppercase. Let's cheat a little bit. Let's see. Yep, it is uppercase with parentheses. This statement right here. So I was right. So what this is the clock allows us to call something for it. So let's go down to where update is and right after the update. So after the update is when we want to wait, but we don't really know how long we're supposed to wait. The Pygame clock does that for us. So all we have to do is call clock.tick, And then inside of here, we want to put our frame rate. So I'm actually just going to call this frames per second. It's going to be a variable name that we haven't created yet. So let's come back up here where our game active is, and let's create that. So FPS, let's set this equal to 30, just because that's pretty standard frame rate. So now, basically, this is the same thing as just putting in 30. I just wanted to be able to change it if I wanted to. So clock.tick at FPS, frames per second. So now, if we run this, what we should see is this blue box moves much more slowly, much kind of more predictable. And to be honest, now it's like way too slow. So what I'm going to do is I'm going to increase the movement speed. So player active speed is equal to 2. I'm going to boost this up to 5. That should be pretty good. And just do a quick test to make sure that movement speed feels okay. Yeah, that's a bit better. We'll have to do some tweaking once we figure out what our enemy movement speed is going to be and stuff. But for now, that's what we're going to do. Also, I want to make this a little bit nicer by setting up some colors, just because I don't like having to write the tuples every time. So we're going to create some colors. We're going to go with black, and black is equal to a tuple of no colors, so 0 red, 0 green, and 0 blue. White is a tuple of all, so 255, 255, and 255. And then, of course, the other ones, which I've just copied because I don't want to type them all out. So red is 255, 0, 0, green is 0, 255, 0, and blue is 0, 0, 255. And of course, you can come in here and create any color you want. Say you want a magenta or like a turquoise. You can, look up the values of those online, or I'm not sure you can put hexes in. I think you need the tuples for most of these. Most things in Pygame understands the tuples instead. So yeah, just look up the tuple value, the RGB value, and you can create pretty much any color you want. So when we say, let's change this up to use our colors now. So when we say self.image.fill blue, now we just say blue, and that references this variable, which references the tuple. So I'm just going to quickly go through here and make sure we're using all of our colors. I know we have to fill with white right here, and I believe this is all of it, because we deleted most of the other stuff that was using any colors. So yeah, so now everything's the same. Still have our blue box, still moves around, nothing's changed. It's just much easier to type a color and, visually understand a color than just a string of 3 numbers, or a sequence of 3 numbers. So let's actually get to creating the ammo, I guess is what I'll call it. So I want a new class for this. And what should I call them? Well, the ammo is also going to be our projectile. So let's just call them bullets, because it's much easier to understand this way. Because bullets are both ammo and a projectile once they've been, given a vector. So class bullets, and we have to define our initializer, so init self. And what are we going to do inside of here? Well, the bullet needs a few things. It's going to take self.image, which is going to be equal to something. Now, what is it going to be equal to? Well, this is where it's going to get a little complicated. It's going to be a pygame.font. Why a font? Because our bullet is actually going to be a character on the key, like the A's we saw. We're going to create a bunch of, characters, as in letters. So we're going to say pygame.font sysfont, system font is what it means. And the system font I'm going to use is, I guess we could just use Arial. That's one of those standard ones, right? Maybe Courier New. I'll use that one because that's the actual font, I think, of the editor as well. Courier New, it's just a monospace font, so it works for a few things. Let's pick a size of 30. That's larger than the example's size, just because I thought the example size was a little small. And I'm going to actually add a bold trait to this font. Okay, so we're using Courier New, font size 30, bold. Alright, that's not an image, that's just a font. How do we turn it into an image? Well, now that we have a font, we can say dot render, And how are we going to render it? Well, what are we actually rendering in this font? Well, just to go along with the example, let's render an A. So we're going to render the string of A, just that one single character. We're going to say true here. I believe this is an anti-aliasing thing. So basically it cuts the edges, or it's some visibility. You know, I should probably check this. So right now is actually a great example, a great time to use this as an example. So let's see. I was looking at images, so let's find font. This is the Pygame documentation. So we're going to click on font. Let's see, we're using system font. We're using render. Let's see, text, anti-aliasing. Okay, I was right, anti-alias. So that's what it is. So I was right about that. All right, so we're going to set that to true. That'll just make the text look a little better versus being kind of pixely. So we'll set it to true, and then we need to set a font color. I'm going to use black, and we're done, I believe. Let's see, this is font.render. Yeah, that should be the font that we need. All right, self.rect equals self.image, image.getRect. And then we're going to say self.rect.x equals what? Let's go with 10 for now. We'll set these to random values later. Rect.y equals 10. And now we actually have class bullets. Bullet, I guess, would be better because it's only one for each object. Yeah, so now we have a bullet object that is just an A. Of course, we can make that a random value, which we're going to do a lot of random stuff in this later if we have the time. So let's see, I want two more, do I? It's bouncing around, so we need to tell it which direction it's moving. So self dot, how should I word this? Do I want X direction or movement in the X direction? We'll go with this. Self.moveX equals 1, self.moveY equals 1. And there's a difference between the two that I want these for, and I'm trying to create one movement that can be used both for when we're bouncing around inside of our box, inside of our player object, and also for when we're being shot out toward the enemy. I'm just trying to create one generic thing, so we don't have to use two. So, let's see. We have our bullet, and it should pretty much have everything that it needs, because we're not going to handle the movement. We're going to have, something like a function called define, what's a good word? Travel, I guess, would be a word that works. And, travel would be, say, when the bullet is shot, it shoots out in the direction, maybe where the mouse is or toward the enemy, depending on how we want to do targeting. And it just travels from one point to the next, and it can't be changed once it's picked its target, because that's how it actually works. And that'll handle the movement. But what actually moves the bullet inside of our player object is the player, because the player is going to handle that itself. So we need a new variable, self.ammo. And this is going to be equal to a list, so we're going to use square brackets. And this is going to be an array, or a list in Python, I believe they're called lists, of all of our ammo objects that we're just kind of holding on to. Let's see, define move. We need two more at least, I believe. Define spawn ammo, I believe is one. And the other one I think we're going to need is define move ammo. That's a good name for it. And we'll just pass on both of these. So spawn ammo is really, really easy to do, because all it's doing is adding a bullet object into the ammo list. So self.ammo.append, which means we are going to add some type of object. And what is that object we're going to add? And we're going to add it to the end of the list, so in the last place of it, basically. So currently there's nothing in the list, so it'd add it to place 0. Then when there's one thing in the list, it'd add it to place 1, then to place 2. So what are we adding? Well, that's actually quite easy. We're adding a bullet. Bullet doesn't take any parameters. That's all we do. Boom. We've added one of these one of these objects right here into the list. And of course, then we can reference that object to tell it how it's supposed to move around. All right, now move ammo. This one is a bit trickier because the first thing we have to do is we have to say self.image.fill and then blue. Why do we have to do this at the start of moving our ammo? The exact same reason we fill our screen with white at the start of our frame. Because if we don't, when we move the ammo, it's going to draw, and then it's going to move, and then it's going to draw, and it's not going to remove the old one. The old one is still going to be there. So at the start of moving all of the ammo, we have to fill it with its original color. And that will blank it out, and then of course we can draw all the stuff back onto the screen in its new position. So how do we find out its new position? Well, once we fill it with blue, we basically need to say this, for, which is a for loop. So we're basically calling for each because we're going to say for ammo in self.ammo, which is saying for every object in self.ammo, we're going to call it ammo. So I guess this could also be easier. We could call this bullet, or we could call this shot. It doesn't matter. This is a variable name. Actually, this is probably the easiest way. For object in self.ammo, what are we going to do for every object, which means every bullet in self.ammo? We're going to move it. All right. How are we going to do that? Let's add some space because moving it is what we do after we kind of check collisions. So basically, all we're going to say is object.rect.x plus equals object.movex. Object.rect.y plus equals object.movey. These are guarantees to happen. So for every object, you're going to do this. Now, the movex and the movey, if you remember, are both set to 1, I believe, up here. Yes, they are both equal to 1. So when we do that, what's going to happen is we actually haven't spawned any, so this isn't going to do anything yet, is they would just move from, they would start up here, and then they would just move down this way. And then say this is the border of our box, they would literally just keep moving out of it. However, we don't have this thing running yet, so we can't see that. So let's take a break from moving the ammo because now it moves. And let's actually just start spawning some really quickly because it's much easier to see when we can actually visualize this. So I'm going to create two variables. I'm going to say spawn delay is equal to delay equals 0, and then spawn delay max equals 30 should be a good value. We're going to come down into our main game loop and draw stuff here. Sure. Fill it with white. Do math stuff. So here I'll actually do it. So what we're going to say is spawn delay minus equals 1 if spawn delay is less than or equal to 0. So if our spawn delay gets below 0 or is equal to 0, then we're going to spawn a bullet. So we're going to say player.spawn ammo, and then we're going to reset the delay by saying spawn delay equals spawn, I keep using caps, spawn delay max. And this will reset the spawn delay counter. So now every second bullets will spawn. And the reason it's every second is because our frames per second are 30 and our spawn delay max is also 30. So this should allow us to now see some bullets spawn. And then they might move. I don't know if we actually told them to. Okay, we didn't tell them to show up either. So this is the issue. So move ammo, we're not doing that. So I actually want to call that now. So right here we'll just say player, actually we should give this an extra space because it's the end of an if statement. Player.move ammo. I'm trying. Player.move ammo. Okay. So now the ammo will move. However, we're filling with blue. We're moving our objects. What's next? Actually drawing them. So we're going to say self.image.blit. Remember, this surface's image, we're going to add something to it. What's that going to be? Object.image at object.rect. So now we should see them. There we go. We have an A. It's moving. And because this thing's surface actually ends down in this corner, they're actually just moving down into the endless abyss. So their rectangles are moving down here, but they're not able to display because they're not at the same position as this. That's funny. I thought they would actually move on to the normal game window, but they don't. So I guess you could do this as a interesting animation for kind of watching things move through it, but we want them to bounce around. We don't want to just watch them move in a straight line. So how are we supposed to get them to bounce around? Well, this is where some logic comes in. So it's very likely an if statement. You can just assume, like, if the thing is hitting the wall, then change its direction. So we can say if object.rect.x plus object.rect.width. What this value is going to be is normally object.rect.x is the top left corner of the screen, which would be, over here in this corner. But when we add the width to it, now it's talking about this corner. Now we don't need this corner specifically. All we need is this side. So if this spot, which is the right side of our square, becomes greater than or equal to self.rect.x plus, no, becomes greater than self.rect.width, which is the width of our square, which is 100. So if that becomes greater than our square, then we know we have actually hit the right border. So what do we do if we've hit the right border? Well, we change the x movement. So we say object.x move, and we're just going to times this thing equal to 1, or times equal -1 to invert its value. So it can't hit the right side of the wall if it's moving to the left. That should be impossible. That's just kind of implicit. If it's moving left, it can't hit the right inner wall. So what this is doing is this is going to say, when we hit the right wall, change our direction by timesing it by -1. Times equals is just how you say times by -1, basically this object times -1. Since you can't explicitly say it, normally you'd have to say times, object dot move times -1, or equals object dot move times -1. Times equals is just the shortcut. So that's what we're going to be using. So let's add another one. So if object.rect.y plus object.rect.height becomes greater than or equal to self.rect.height object.y move times equals -1. So now when we've hit the right side of the wall or the bottom, the right side or the bottom, we should switch our movement. And let's see if this works. So now we're watching it, and it crashes. That's interesting. Bullet instance has no attribute Y move. It doesn't? Move X, move Y, not X move Y move. Oh, so it doesn't actually have an attribute of either. X move, Y move, move X, move Y. I actually like that better. X move, y move. There, now it does have the attributes of those. And we'll change these x move and y move. There. So now it should work, now that we get no errors, right? Yep, there, you see they're bouncing. And of course we haven't calculated how to collide off the top left, so again, they're just kind of bouncing in and flying back out. So we probably want to fix that. So this is going to take 2 more if statements. These ones are slightly different because these are the top left corner. So all we have to do is if object.rect.x becomes less than or equal to 0. Oh no, that just seems shorter, but I guess that's right. So if the thing's rectangle, the top left corner becomes less than 0, then object.xMove times equals -1. And if object.rect.y becomes less than or equal to 0, then we know we've hit the top. So we can say object.ymove times equals -1. And that should calculate all of the various collisions. Let's run that to check it, make sure it's working. Bounce, bounce, bounce off the top, bounce off the left, and there we go. Now if you notice, one weird thing is that they're bouncing kind of high off the bottom. That's just the text objects. The surfaces that they use are usually taller than they actually are. Now if you notice, the left and right are okay for, where they hit, but the bottom is the only real one, sometimes the top too. That's just the size of the rectangle, any bit that's off for this. Now, you see it moves nicely, and none of these A's really care about this thing moving, which is nice because we're drawing them onto the actual blue rectangle surface. We're not drawing them onto the game screen. So they're just being drawn directly onto the blue rectangle surface wherever it happens to be. So we don't even have to really care about the blue rectangle's position at all. Now, as cool as this looks and as trippy as it is to look, I prefer them to be random just because this is way too mesmerizing to be able to play a game and look at. Maybe you guys can be the judge of that though. So do we want the cool trippy thing, or do we want the more random thing from the other example where, well, they're smaller and they spawn slower, but these ones are more random? I don't know which one we want. I'm going to show you guys how to do the random one because that's honestly my preference. So let's go back to where we do our move ammo. Oh, it's right here. No, we don't do move ammo. We go back to our bullet. That's how we get this. Actually, we go to the top. I'm really good at direction. So we need to import another thing. So I'm going to put a comma, and I'm going to import random. So what are we going to do with random? Well, when we set our X position, we're actually going to do random.rand int, and now we give it a range. So you can spawn from pixel 5 to, I'm going to go with 75. That seems like it should stop any collisions, weird collisions. And of course we'll do the same thing. So random.rand int from 5 to 75. So now what this is doing is self.rect.x and y are going to be a random number between 5 and 75. So they're going to randomly get pushed inside of our blue circle. We don't really know where they're going to be. And x move, we want to do something random as well. So I'm going to say random.choice. And I'm going to give it a list, which is square brackets, of 2 choices. And it's going to pick one at random. It's going to be -1 or 1. The reason I don't say random int between -1 and 1 is because it could pick 0. And I don't want my object to have its position starting at 0, because then it will only bounce left and right, and it will never actually form, a weird kind of bouncing in circles inside of the rectangle. And I want all of them to do that. Now, if you want them to sometimes maybe just go up and down or just left and right, then you can do a random rand int range from -1 to 1. But personally, I just want it to be -1 or 1. Those are the only things I want. And it's going to pick either one. And of course, maybe you can put more in. Maybe you want it to move faster or something. So you can do, maybe the x instead of -1 or 1, you can do also -2 and 2. in which case then it maybe has a 50% chance to move faster. Whatever you like. So now you'll see they all bounce around randomly. We can still move our blue circle. They still spawn. Everything is working. The only difference between this and the example at this point would be the fact that they're larger, which just makes them easier to see. Now, we've gone, again, as pretty much every single episode, I want these things to sit around 20 minutes, but they always go to half an hour. So thank you guys for watching. Hope to see you next time.